welcome Professor Percy Liang, who's our next keynote speaker. Percy is an associate professor of computer science at Stanford University. He has his PhD from UC Berkeley. And he's also the director of the Center for Research on Foundation Models and a co-founder of Together AI. His research spans many topics in machine learning and natural language processing, including robustness, interpretability, semantics, and reasoning. He's also a strong proponent of reproducibility through the creation of CodaLab worksheets. He has multiple awards. His awards include Presidential Early Career Award for Scientists and Engineers, IJCAI Computers and Thought Award, NSF Career Award, Sloan Research Fellowship, Microsoft Research Faculty Fellowship, and multiple paper awards at lots of prestigious AI and ML conferences. So it's my pleasure to welcome Percy again. Percy, please begin. Thank you.
Hey, thanks for the kind introduction. All right, thanks everyone for coming. So today I'm going to be talking about benchmarking, which is a topic I've been thinking about for a long time now. But we are now living in the era of foundation models, which makes things extra interesting. And I think there's a lot of people talking about how benchmarking is broken, we don't know what to do. And I think that is all true, which makes this field much more exciting. So let's see, can people see the slides? Okay, great. So I'm going to start with a few general thoughts, and then I'm going to talk about some concrete projects. So I want the way that we think about benchmarking is that benchmarks orient AI. So historically, it's been quite clear with benchmarks such as ImageNet, Squad, Superglue, that benchmarks have driven progress in AI. And I don't think we would be here today without all these benchmarks. And one thing to note is that benchmarks are encode values, right, implicitly. Maybe you don't think about them when you just download a data set and run it and look at the number. But they actually, if you think closely, they encode values, what the community cares about, what tasks do we work on, what languages, what domains, and so on. So I just want to keep that in mind as we go through the talk. So here's a cartoon, a picture of how I see the world benchmarking. So for a long time, ever since I guess AI became more statistical, we have these challenge data sets. So the Penn Tree Bank and natural language processing, MNIST, TIMIT, ImageNet, Squad, etc. And these, in this era, you defined a data set, and that was sort of a North Star. And over many years, even many decades in some cases, people would strive to do better and better. And this was quite useful. And I think this is really important because it led to some kind of paradigm shifts. For example, ImageNet 2000 was released in 2009. And that was before deep learning really swept computer vision. And a lot of the computer vision community was skeptical. But then, of course, everyone knows, and AlexNet came in 2012. That was afterwards. So without ImageNet, I don't know what would the computer vision community be doing. So I think benchmarks have this objective quality to them that allows researchers to kind of flow between paradigms. And that's very, very important, I think, for the health of a community. So then around, now speaking maybe more for NLP and in the language models area. So then there's this, what I call cat and mouse era, where around 2018, it seemed like BERT was coming out, and it seemed like the field was making a lot of progress. And there were a lot of papers, including some of mine, that said, hey, we have this new challenge data set. Look, the gap between human level performance and these, the state of the art is very high, except for in a year or even some 6 months, that gap just shrinks. So, it's humbling, but that is what it is. And now we live in maybe despondently I'm calling the post-evaluation era, where people post screenshots on Twitter about, here is a prompt and I got this GPT-4 to do XYZ. And no, forget these academic benchmarks. We don't know, we don't care about evaluation anymore because these models are so good. So you know, and this is just because models are capable of so much more than what the benchmarks capture. In stark contrast to when we started doing statistical machine learning, benchmarks were captured way more than what models were able to do. So we see this kind of reversal. So there's a question now, so are the benchmarks just too easy? Are we just saturating them? And that's a problem. So I don't think this is quite true. So often I hear, well, we've gotten human level performance, so that benchmark is worthless. But it's a little bit more subtle than that. First of all, we're not getting 100%. So even GPT-4 on MMLU, which is a broad question answering data set, is 86.4. So that's a B, right? It's not like it's getting 100% accuracy. But in case that's still too high for you, there's ways to make it lower. You can evaluate more on distribution shifts. You can reduce the training data size, reduce the model size, and we can maybe feel a little bit worse about the models. But fundamentally, I don't think that changes everything because you can always multiply by 3, right? So sometimes you measure accuracy, you multiply by 100, so the number looks bigger than like accuracy of like 5 or 0.05. Okay, so. But the point is that the existing models aren't saturated. You can always, these are good questions that people actually spend a lot of time making, so they're valid. But I think what's missing is that there's other things that we're not looking at, other things that are opened up by these language models. So I want to take a step back and think about benchmarking in a broader light, and the framing I'm going to use is measurement. So measurement exists very broadly in many fields. So in science, we think a lot about developing tools such as the microscope and telescope. And this measurement it's in some ways all about measurement. If you can measure things, then you unlock new science and you can do amazing things, right? In standardized testing, we've been struggling for centuries to assess how good is a human being at some cognitive task. And you could argue that we haven't done a terribly good job here, but this is measurement of a general cognitive capabilities of a person, which has been around for far longer than AI. And then at the sort of more societal level, there's indexes. So popular indexes include like the Human Development Index, or if you even think about GDP, these are ways to measure social or economic concerns. And these are also have a long history, and they're trying to measure fairly complicated things. So what am I trying to say? I'm trying to say that often maybe we should think about the abstract constructs that we want to measure. For example, productivity or human rights in the case of economics. But for language models, maybe this reduces something to, well, we want to think about reasoning abilities or bias or creativity or interaction or ethics. And the question is, how do we quantify these notions? Right? All too often, I feel like the field just races ahead and you collect a data set because it's convenient. And we don't really think about the underlying construct that we're trying to measure. So you have a question answering with like math problems. What are you measuring? Are you measuring something about reasoning or about test taking abilities or so on? So I just want to put that out there as a thought. Now I'm going to talk about some of the concrete projects that I've been working on with my students and my group. Starting with the holistic evaluation of language models. This was co-led by Rishi Pamaswani and Tony Lee, and Ifan in the middle has been the lead maintainer of Helm going forward. So, excuse me, I need some water. Feel free to ask. Are we doing questions during the talk? Okay, later. Okay, so here's why evaluating language models is hard, because they're too simple, right? The language model takes a prompt, which is an arbitrary piece of text, and then produces an arbitrary piece of text. So that's as general as you want it to be, which means that there's an immense capability and also risk surface. They can do almost kind of anything you can imagine specifying language, if you think about language as universal. So that's pretty daunting. So in Helm, we decided to take a methodical step to try to figure out how to think about this daunting space. So, and often, as I mentioned before, people just put in benchmarks. We'll evaluate this. We'll evaluate that. More for convenience, which makes sense. But we wanted to go a little bit more top down rather than bottom up. We designed a taxonomy that captures all the various different tasks. The tasks were taken from a combination of what's in the literature versus what's are the applications that people are using in practice, and then across with the domain, which includes who, what, when, and the language. And of course, we can't cover the whole space. It's a combinatorial space. We don't have benchmarks for sentiment analysis for movie. Let's see. Sentiment analysis. Well, follow one of the edges there, and you get a it's with probability, high probability, you'll get something that's not there. But I think this is helpful. So this is having a scaffolding for thinking about what we would like to measure aspirationally versus what we actually have. And then this finds some sort of roadmap for creating new data sets. And if we're feeling that a particular area of maybe low resource languages is not represented, then we can actively fill that gap, as opposed to just having a laundry list of benchmarks where I don't know what's there or what's not there. Okay, so that's the first principle. The second principle is multimetric measurement. So often in benchmarking, you have a data set and it has a principal metric. Usually it's accuracy, but if you have like a bias data set, it might measure some notion of bias or toxicity or so on. But our view in Helm is that accuracy is only capturing one aspect of what you might care about in a real-world deployment. There's accuracy, there's calibration, robustness, fairness, bias, toxicity, efficiency. Again, these metrics were also taken from what do people care about in the field, what have people done research in. You can read the paper for more details. It's a pretty long paper that talks about how we arrived at all these criteria. And then third is standardization. So this matrix now shows the set of scenarios or data sets crossed with the models, the top one. It's a little bit small. Despite papers generally doing a lot of evaluation, we realized that the matrix is not that dense. So maybe papers evaluate on different benchmarks, or some models actually, some of the commercial models were at that time not evaluated on any of the benchmarks. So what we did was to systematically evaluate all the models on all the scenarios in a standardized way. Okay, so this part I'm going to go through quite rapidly, just because I have more things to talk about later. But if you think about the scenarios, just to give you an idea, we looked at question answering, information retrieval, summarization, toxicity, classification, sentiment, some text classification. And then for the metrics, we, just to anchor a little bit more, we looked at accuracy, which can sometimes be just a metric that's automatically evaluated, or sometimes it requires human evaluation. We looked at calibration, which captures whether the models know what they don't know. And it turns out that this is not that great. Models are often overconfident, and especially the instruction-tuned models are very accurate, but also very confident. So this is a good thing to track. Robustness, what happens if you introduce synonyms and typos? Does it flip the prediction? If you change the gender, then does the prediction get altered? Some bias, correlation between generation of gendered words versus some target words. Toxicity, we run a standard toxicity classifier to see whether the output is toxic. Efficiency, so you can measure wall clock time on an API, but that hides a lot of things. So then we look at more white box approach as well. So I guess the bottom line is that we think about evaluation not as just an array, but as a matrix, where we want to lift all these non-accuracy metrics as first order concerns. So whenever, the ideal is whenever you create a benchmark, you don't have to, you're not just measuring accuracy, but you're also measuring all these other things and for free. So you can think about it as what we did in Helm is we factorized tasks into scenarios crossed with metrics. Okay, so for the models, we basically grabbed everything we could get our hands on, including open models and closed models. The only things that we couldn't were some of Google and DeepMind's models, but we had some access to Anthropic's models at the time. And results, I'm not going to show a leaderboard, but because this is like from a year ago and it's all the models and things are out of date. But I will mention a meta point, which is that all the results are on this website, and by all the results I mean all the tables with the numbers of the models and the scenarios. But also, if you click on a number, you can see the instances and the model predictions for each of the instances. And if you click further, you can see the exact prompts that we use. So I believe in full transparency because we know that prompting decisions can have a big impact on what the accuracy looks like, and we just want to be transparent about here's what we did because there's no right way to do this, but at least we can say what we did. Okay, and also for more generative tasks, I don't believe any of the numbers. You have to look at the output and you judge for yourself, does this look like a reasonable output or not? So all the code is available, and actually what has been happening is that Helm has been transformed more into a framework, which is more modular so that it provides a general way for if you have a data set, you can just come in, plug it in, and run it on all the models because we standardize everything for you. Or if you have a model, you can come in and then you can run it on a bunch of data sets. So please check it out. Yifan is the lead maintainer of this, which he has been really great in making sure that this is not just a one-off research project, but a piece of infrastructure that's enduring. So we've been updating this over time, but honestly, it's been every week there's something. So we're trying our best to keep up. Okay, so let me talk about some projects which are not exactly Helm, but have been inspired by Helm or have followed out of it. So we've been now looking at text-to-image models with Tony, Michi, and Chenlin. And this is applying the same holistic principles of Helm where we think top-down, what are all the things we care about for a text-to-image model? And we listed a bunch of these aspects, including originality, whether it is biased, robustness. So this is the most comprehensive evaluation of text-to-image models rather than, well, you generate and then you post on Twitter and then you're done. We've been also looking at human LM interaction. I think this is an important point. So when language models are deployed in the real world, it's usually used by a human, and that interaction between a human and the LM is iterative because you're trying to usually have the human has some high-level goal, and then they type some prompt to get something, and it doesn't work, so they try something else. And we want to capture that whole process, not just automatic one-shot evaluation or even dialogue. So we produced a framework called Haley, and we looked at 5 different tasks: dialogue, question answering, solving crossword puzzles, text summarization, metaphor generation. And the key thing about these tasks is that the human is on the hook for producing the answer, and they can prompt the language model however they want. Okay, so we run these tasks, and so the cube in the left I think shows something really interesting, which is that if you think about how we're evaluating models right now. It's just one corner of that cube, which is we only focus on the output of the evaluation. It's usually third-party evaluation, like objectively, how good is this output? And we focus on quality. But we look at the other dimensions when we think about human LM evaluation. We think about the whole process, not just what the final output looks like. We think about, well, the first person experience. So we ask the person, the user, well, did you trust the model? Was it a fun experience? And it's more qualitative in that way. And then we look at preferences as well. And then the punchline is that the automatic metrics are often correlated, but not always this identical to these interactive metrics. Of course, using GPT-4 is going to be better than using GPT-2 for interaction in, I think, probably all cases. But once you look at two models which are comparable in automatic metrics, I think some of these interaction design decisions, for example, building trust, I think really matter. So speaking of kind of human interaction, I think one of the main ways that we might interact with these language models, at least on the consumer side, is these generative search engines. So think about Google's generative search experience, or Bing Chat, or Perplexity AI, or U.com, any of these things where you type in a question and the system goes and retrieves a bunch of documents from a search engine, and then it gives you a response. And then we know that LLMs lie and hallucinate. So, but fortunately, these providers have put in these citations. Okay, so that's good. But how good are these citations? So this paper is about investigating this, and we found out this was in early summer, so things might have changed right now. Is at least at that time, it was not very good at all. So only 74% of the citations actually support their statements, which is like shockingly low if you think about, just shockingly low. And there was this interesting trade-off between perceived utility and citation precision recall, which meant that systems that try to be faithful to the text would often just copy paste from the citations, and then it was good for being faithful, but it was perceived as not that useful because you're just copy and pasting. Whereas the systems that more aggressively just produced a nice output for you were perceived as useful, but often this sort of deviated from the actual citation. So that's an interesting trade-off that we revealed. So one of the main things driving these generative search engines are these retrieval-based augmented systems where you retrieve a bunch of documents, you put it into an LM context, and then you start generating. And and if you retrieve a bunch of documents, and a lot of documents, you need a pretty long context. But fortunately, over the last year, we've seen a lot of interest in people developing long context models, and now we have even like 100K tokens, which is you can fit like a whole book in there. But how good is this context? So we evaluated this. This is again Nelson, the lead author here, on the problem of question answering on natural questions where you retrieve a bunch of Wikipedia documents, you put it in the context, and what we observed was something interesting. So on this graph, you see the position of the document where the answer is. And on the y-axis, you see the accuracy. So you see that model, so this is a GV 3.5 turbo, is that when the correct answer appears at the beginning or the end, the model does pretty well or better. But when the correct answer is in the middle, it's actually worse than the red line, which is not using any retrieved documents. It's just like hallucinating. So It's just not great. So I guess the lesson here is that when you see a model is advertised as having a long context, you should hold your wallet and ask, does this model actually process this long context? It kind of reminds me of maybe a year or two ago when everyone was all about number of model parameters, and you could here, I have a 500 billion parameter model. And you should, at that time, obviously hold your wallet too, because I can give you a 500 billion parameter model for free. So again, the numbers need to be contextualized with actual performance. Okay, so let me switch gears now and go think about beyond models. So we talked about benchmarking models, but I think there's something really interesting about the ecosystem in which models can inhabit. So agents. So I think there's a lot of interest in agents these days, and I'll talk about two projects that are and what I think about them. So the first project started about a year ago with the lead author is June Park here, and we decided, well, language models are pretty good at just, if you think about them generating text or code or whatever, how far could we push this? Could we simulate a city, right? And, at that time, there was, you could always already been thinking about, okay, well, agents with some tool use, and they're not just, and maybe if you think about dialogue agents, clearly they're just, you can think about agents. But I think the key thing about this that made things click is think about the multi-agent setting. So not only do you have a single agent that's trying to do some tasks, but you have a whole city of 25 agents that are somehow interacting with each other. And I'll show you some of the interesting findings here. So there's this little virtual world called Smallville, and the agents in this world that we built go and do things in this world. So they get up in the morning, they brush their teeth, take a shower, then they talk to each other, they pack up, go to work, come home, and have conversations with each other. So all the traces are online. You can watch the simulation for hours if you really are bored. And how do we build these agents? So this is the key model architectural diagram. It's based on a bunch of things in the kind of agent literature. Actually, some of this goes back way back to the old school agents. But the idea is that you have an agent, it perceives things from the environment, which are observations, and it adds it to the memory stream. And the memory stream is just a log of everything that the agent has seen. Okay, so then at any point in time, the agent has to retrieve some memories, and then using those retrieved memories, now it's a smaller context, it fits into your language model, it can make plans about what it's going to do, which goes back into the memory stream, or it can reflect, it can think, these are some nice memories I had, what do I think of this? And then based on that, you can also perform actual actions. Okay, so that's the general architecture. And just as I'm not going to have time to go, let's see, too much into this, but memory stream is just a list of natural language statements. And, because we have language models. And then based on, the retrieval is based on a number of things, including how important something was and how recent was something and how relevant something was. And then, reflection, I think, is a really interesting operation, which takes a bunch of experiences. For example, the observation is Klaus Müller is reading about urban design, and you abstract things. And then at the end, the reflection might be Klaus Müller is a highly dedicated research. So you generate some abstract thoughts, so you can think about this as, chain of thought or any of these other things, but in an agent setting. So maybe one thing that I want to emphasize is that by thinking about agents and not models, we had to confront some of these agent architecture questions, reflection, planning, action. I think this is a fairly well accepted way of kind of building agents now. But I think the interesting thing is that when you have multiple agents and not a single agent, you get some emergent behaviors. We like to think about emergent behavior in language models, but there's also a different type of emergence when you have a bunch of agents, whether human or artificial, running around. So one of the things we did was that we told one agent, you're going to plan a Valentine's Day party. So then the agent goes and invites their friends, and then people actually, not everyone, but some people were busy, but some people showed up to this Valentine's party, and someone asked another person on a date. So you can think about this, how information propagates and how individual actions by one agent can influence a whole community of agents. That's really fascinating from a social science perspective. So, I think this is very fertile, ground for new research. So two things I will mention. One direction is that these agents are, they're not perfect, but I think they're pretty, believable. And if you want to develop games, which people are now doing with this stuff, it's probably fine because you just need to be, it needs to be believed. But in a completely different community, we've been engaging in with social scientists and people from economics who want to actually, they see this away as a simulation that could further their science, and there the bar is higher. You need to not just, yeah, it looks good. It needs to actually reflect what's going to happen. If you're going to make policies based on how people are going to behave based on the simulation, it better have some validity to it. And so that's a much deeper question, which we're trying to grapple with. But I think the possibilities here are pretty interesting. If you imagine there's much of things, think about like COVID policies, which you can't just like run them in the world as easily. But if you had even a semi-accurate simulation, you could simulate, and then you could see what happens, and maybe that is informative. So that's some food for thought. The second direction is this idea that an agent's ability is not isolated. So this is certainly true for humans, right? How good someone is really a function of how well they fit in with the rest of society, because you can't be alone. And if some people are really good at surviving in the jungle, but they'll die in the city, and vice versa. And some people will be better in let's say a corporate environment versus in the theater. And so I think this is an important kind of realization from the multi-agent view that we've been taking. And so you can think about evaluation and benchmarking as agent, not as just an isolated, hey, how well are you working on this standardized exam, but how successful is this agent? You plop it into this virtual world, and does it thrive or does it not? And I think this is maybe a interesting take on benchmarking, which might be in some ways more realistic, way to think about evaluation that carries over to the real world. Because when you hire people, it's really how well do they mesh with the team you have and work together and so on. Okay, so here's another type of agent I'm really excited about. So this is a work led by student Chen. So number of us do. How many of you run research experiments? Okay, so some of you. Well, some of you probably have run research experiments in the past at some point, and it's it's just a process where you're trying to do something. You write some code. You run the experiment. You look at the results. And then you go and debug your code or modify your code, and maybe you read some papers and so on. So it's a process. And the key question here is, can a language model in an agent do this? And the answer is not yet, but we wanted to find out. Okay, so here's the basic idea. So we have LLM. We're going to give it some prompt, some really insanely long prompt that tells how to do research and so on. And then it's going to take, actions, which might be, reflections. So again, borrowing the ideas from, the previous generative agents work. It can make a plan about, what am I going to do next? And it can fact check, which turns out to be important. It can just think, it can execute scripts, and can edit, look at files, and based on external actions, it gets some observations, and then everything is added to a research log. And the research log is like the memory stream from before. And this is actually great. I wish everyone kept a very meticulous research log of everything they did. So maybe this is better than what we're doing already. Okay, so that's basically how it goes. And we chose 15 different data sets or challenge problems, or I guess you can think about more of that as environments. So many of them were Kaggle competitions, but we also had ones which were more, more recent, like for example, this baby LM. Some were about improving the speed, and some were just building a new tool. And the results, we evaluated GPT-4, Claude, and there's a lot of white space here. It's uneven for some of the older Kaggle competition, older data sets where there's probably plenty of stuff on the web. It does pretty well, but for some of the new things, it's getting zeros. Okay, so I think gap between human and state of the art is high. So maybe I can be a little bit bullish that this benchmark will last more than 6 months. Okay, so here's an example of some of what the research log looks like. So, okay, so you're making a plan and a status. You understand the train.py strip, got familiar with the model architecture. It's a simple CNN data set. Is CFAR. I guess CFAR is one of the ones that it does okay on. And then it comes with a plan. You can try different parameters, hyperparameters, regularization. You can change the model architecture, and then it defines a baseline, runs it. You can kind of read the rest. So it's pretty interesting. So this is still a challenge. Doesn't work that well yet. But one thing I find is an intriguing aspect of this. This is not just any benchmark, but this is a benchmark for research. So what happens if you improve the model, then you have an agent that can maybe do research better, which enables you to improve the rate of improvement for models. So I'll leave you with that thought. Okay, so let's see, I have about 5 minutes. Okay, so I want to switch gears a little bit. This is still under the umbrella of beyond models. And I want to talk about transparency. So first of all, we need to think about, we often fixate on these models because they're really cool. But it's important to realize that there's a whole ecosystem where there's people who create the data, like the writers who write the books. The data gets curated or scraped, that goes into training. This gets adapted to some product, and then it gets deployed. So it's actually a pretty long process. And if you think about from other industries, you think about supply chains for any sophisticated product, it's much more complicated than this. So this is not even that complicated. But the point is that let's think about the whole ecosystem first, not just fixate on the model. And we want to evaluate that ecosystem. So the motivation where we started was, okay, everyone talks about responsible AI. And so we're thinking about, okay, what does it mean to evaluate whether AI is being developed responsibly? So of course you can measure the models, but as I mentioned, we need to think about everything, and certain aspects like privacy aren't about necessarily the model, they're about the relationship between the data and the model and the predictions. And then we realized that you can't get very far with valuing responsible AI because we don't know what people are doing. And by people, I mean, organizations with training big models. So the prerequisite is transparency. And transparency has been this thing that actually has been advocated for in many other settings, including social media. So when companies have policies and aren't transparent about what they are, then bad things can happen. It's also important for researchers because if you don't, let's say, know what a model is trained on, and you evaluate, then how do you understand whether this was just contamination or whether this is true generalization? It's obviously good for consumers. Think about nutrition labels. We want transparency about the food we eat, and a lot of people in policy are advocating for transparency as well. Excuse me. But unfortunately, transparency is waning. Over the last 3 years, we see that while I think the 2010s was a glorious era where people were publishing openly and releasing data sets and code, starting in 2020, the transparency is getting worse and worse. And so this is not about the models now. This is about the the organizations. So how do we concretely evaluate transparency for organizations? Okay, so that's here, and this feels more like what if you're thinking about economic indicators as opposed to classic machine learning benchmarks. But there's actually quite a bit of similarities. Okay, so here's the main result or table. So what we did was we took 10 organizations, each with their flagship foundation model. So for example, OpenAI, GPT-4, Google PaLM 2, and so on. And then we defined 100 different indicators which are grouped into categories such as transparency about the data, transparency about the labor, compute methods, whether you have model access, whether the capabilities and risks were evaluated, whether there's mitigations that were done, and whether there was some revealing of, hey, what did you do to make your model safe, to downstream, which is how are these models being used in the real world? Do you have usage policies? If something goes wrong, is there a mechanism for feedback, and so on? So you see a lot of red here, which means that, and some zeros too. So it turns out that things are not so transparent. And one thing that might be, okay, so here's the actual scores. I wouldn't worry about the ranking too much. I think the first order bit is that everyone is, the highest is only a 54. And so that's I guess I'm an I grade student, so that would be an F. But I think there's one statistic which I think is interesting, is if you look at for every one of those 100 indicators, is there an organization that gets that? And that number is 82%. So it's not that we have some crazy indexes that no one is getting on. Like the exam problem that no human being can ever prove P equals not equal MP or something. These are all achievable, and they are achievable by one organization. In fact, if you look at 2 organizations, then it's it's 70, which is still quite a bit better than how we're doing here. So if you break down by the upstream versus model versus downstream, so upstream is about the data and how your model was created, and downstream is about if you're keeping track of what's happening to your model. So let's see. So the open models do. Let's see. Okay, so if you look at some of the open models, they do quite well in the upstream, because especially things like Bloom, where they actually did a really fantastic job of being completely transparent about how their model was developed. But one thing that I think is maybe interesting, that this is not about closed versus open per se. This is about transparency in a very broad sense, which is why you don't see like the open model is getting 100 and the closed model is getting 0. It's, I think, a much more nuanced notion than that. But nonetheless, the open models do quite a bit better than the closed models. And OpenAI does, in terms of aggregate score, it's pretty good because they spent a lot of effort on thinking about usage policies and risk mitigation and things like that. So that's part of the transparency as well. Okay, let me wrap up now. Okay, so I'm just at a little bit over time. Okay, so I started with this claim that benchmarks orient AI. I do think that is a very powerful tool for both understanding the status quo, where are we today, and tracking that over time, but also incentivizing improvement, where improvement is defined by what the benchmark, how the benchmark is defined. So it's a very powerful tool, I think, that's maybe less explicitly appreciated, I think. I would think, maybe leave you with a thought that we should think more about the measurement of the abstract complex construct. Like, what are we trying to measure, as opposed to just grabbing and collecting whatever data set we feel is convenient? Because I think there are a lot of things, for example, this transparency thing that I just talked about. It's really about that abstract construct of transparency and anchoring and grounding it out rather than something else. What makes all of this difficult is that it's unlike a model that was developed to classify spam, where what it's supposed to do. You have these models that are just general purpose, and I don't like anthropomorphizing, but it's the same problem we have with humans. How do you evaluate humans? It's almost impossible in some way. I talked about multiple directions, multimodal, which is, I think, obviously going to be a big deal. Interaction, which I think is still underappreciated. We did some work, but I mean, it was hard to have humans in the loop. Talked about long context. And then finally, beyond models. I think agents is, I'm not the only one that is excited about agents, but more specifically about thinking about the multi-agent context and how individual agents fit into a larger organization, I think is really an interesting question. And this idea of self-improvement kind of tickles me. And then the other way beyond models is thinking about the organization, right? So we focus a lot on just the model and on the technical aspects, but it is really important to realize that these models are developed in a social context with certain organizations, and there's practices, and there's people who are producing the data, and people are getting either the benefits or the harms downstream. So it's a much more contextual story here. And thinking about that leads us to think about, well, the whole pipeline, and then the organization is the unit that can be evaluated because it has to span that whole spectrum. But I talked about a lot of things, but hopefully this was interesting to you, and I think it hopefully gives you a much more expansive notion of benchmarking. So thanks.
Thank you, Percy, for a fascinating talk. We are running late, so we'll have only a couple of questions.
Hi, awesome talk. I want to pick your brain on the evaluation method. I think these automatic metric like root score or even like burst score, right? These are really broken and ill-suited for generative AI tasks, right? So I think you had the success using large language models in your alpaca farm work. So should we just really sort of, essentially using large language models to evaluate other models, right? And then with human oversight, because these models has biases like the position bias you mentioned and lens bias and favor its own style, things like that. But you can sort of have human oversights, experts, which really you can sample, right? Some of the prompts and make sure that you don't have those biases. Is that the new gold standard?
Yeah, so I think model-based evaluation using a language model to evaluate, I think is a really useful idea because it's reproducible and it's in some cases actually quite good. But I don't think the issue is whether it's using a language model or a human. I think the issue is that we're not very clear about what we want to evaluate, period. So a lot of these language model evaluations like generate a story about or a trip itinerary or something completely open-ended, and then you're given this and A and B and tell me which one is better, or you're giving me a Likert score. It's pretty difficult to even think about what am I evaluating here? And I think the main thing that's missing is thinking about rubrics, right? So, again, kind of drawing from my own experience when I, grade an exam that's open-ended, how we evaluate is we come up with a bunch of rubrics that make the evaluation meaningful. Otherwise, it's the variance is huge and you don't know what you're doing.
So your rubric could be part of the prompt, right, to help the language model to evaluate, right? That's much better than a root score or BERT score, right?
Yeah. Yeah, I agree. I'm not advocating for Rouge or BERT score at all. I think that the rubric is useful both for models and for humans, but I think that's the thing that's missing right now.
Hi, thank you. Very interesting talk. And this ML research agent kind of work is quite interesting. My question is, let's say you mentioned OpenAI generating the research plan, and then part of it gets executed. Now, like sort of, that's kind of using the generative LLM text generation. You can also think about inserting the task and training the LLM to not just generate the text, but generate the task interleaving. And I'm just wondering, like, sort of, like, you have mentioned the OpenAI as one tool to generate the research plan. Have you explored, like, sort of other ways to train the LLM to generate the research plan?
Sure. I guess the figure had the OpenAI logo. I didn't mean to promote OpenAI's model or anything. In fact, we use both OpenAI and Claude. So and also if once the open models are good enough, I think we can try to use those as well. I'm not sure I completely got the question about inserting the task. I guess maybe one thing is these are agents that we're prompting right now, but you could imagine fine-tuning the agents based on these experiences. Right now, the only learning that happens is you collect this research log, which can be pages and pages, and you can retrieve from that memory, but you're not fundamentally compiling that knowledge down into the weights, but you could imagine trying to do that. And given that some of these benchmarks there's an objective measure, you're just trying to increase accuracy, you can even imagine RL-based approaches too.
Thank you.
So about the generative agent topic. So in the directions you mentioned, so we are going to have valid agents for simulations. So would you talk a little more about what's the effort we are making to have the valid agents? Or what's the current limit that prevent us from have more valid agents?
Yeah, so the question is, how do you assess validity? I think one thing that is difficult in this virtual environment is that it's not a real environment to begin with. So in some sense, how do you know what ground truth is? So that's sort of ill-posed. One thing that we've been thinking about in the social sciences, there's all these experiments where you do studies on people, maybe groups of people, and you get some sort of response distribution from them. Can you sort of mimic that in using LM agents? And this and we've been able to get some success. I mean, it's not full correlation, but it's I think it's promising. But this is still, it's very context dependent, right? I don't think you can fully say, oh, we've solved the validity question. It's going to be depending on what environment you're dealing with.
Okay, great. Thank you.
One last question from here, and I would ask the speakers for the next two orals to be ahead near the presentation area.
Yeah, so hi. So I had worked at a machine learning startup a couple years ago, and we ran into this issue of bias in the data sets, specifically around, hats, and then specifically Mexican hats. And then, there were no training data involving like traditional Mexican hats from people from Mexico. If you Google Mexican hats, the thing you see is like, white people in Cinco de Mayo. So there's obviously like a huge deficit in how you basically can train data with indigenous cultures, for example, because there's not as much available data about indigenous cultures. And then so my coworker and I were talking about like, what if we kind of like think about a benchmark essentially of like, kind of curating a data set of minoritized populations, and then that way you can actually like test it. You can test your AI against this data set. But then we ran into the issue of like, how do you curate such a data set that isn't exploitative of these minoritized populations in the first place? And then B, how do you make sure that it's not just scooped up by, the idea that we had was kind of like, if you had this benchmark data set that people could, test their app against to see how well it did with these minoritized groups, but then how do you make sure that they don't just like essentially steal that data set to train their data set of the future? But then I feel like the problem with a lot of these kind of concepts about like creating these good benchmarks is that they do, to get those edge cases involves a lot of vulnerable communities. And then also to kind of like get the best, or to get a robust data set is extractive at a certain point. So like, how do you reconcile with that kind of tension between benchmarks and also like extractivism?
Yeah, that's a very, very rich question. Happy to talk more about offline, but just some brief thoughts. First of all, I think the rise of foundation models makes it actually really interesting because it's possible to develop a much broader set of benchmarks for different communities than it was possible in the past. Because in the past, in order to evaluate ML, you have a training set and then you have a test set, and it just takes too much data collection efforts. But now you just have to curate a test set because we think that transfer learning works. So it opens up more possibilities. Now that said, I think there's maybe two issues: the exploitation aspect, and then there's the scientific validity. So on the validity side, it is true in general that once a test set is used, you can think about maybe people are gaming it, or it leaks into the training set or whatever. So you have to be careful. You can have hidden test sets. You can try to. We've been doing some work try to audit the training data from these models to see if there is actually overlap. But the only robust solution is to collect new data, which in the marginalized community setting is perhaps even more problematic because you have to go back and extract more. For the extraction piece, I think this is a really interesting question. Obviously, at the individual level, you can imagine things like consent. Obviously, that's a bare minimum. But maybe one thing to think about is incentives here. If these people are donating their data or giving their data, what are they getting in return? Are they aware of the consequences of this? And building up more of a framework for thinking about the consequences, and also retraction, I think, is important here. If you decide like, oh, actually, never mind, then being able to retract, which is also a very hard technical problem because once the data is there, then you can't really remove it. But yeah, very fascinating, rich question.
Thank you.
Thank you, our speaker, Percy. And